IIT Guwahati. Today we are going to discuss about some problem related to analytical techniques, which is coming under the course PT40 for medical biomaterials. So here comes the first question. Biofilm forms on any implanted surface. Which process that occur here has the highest time scale? So please raise your hands, whoever know the answer. And so anyone, what will be the correct answer? So can anyone tell me how many processes are involved during the biofilm formation? Any answer? Which all the processes are involved? Anyone? Okay. So the correct answer is okay. So the correct answer is biomass growth. This is because biomass growth. Just a minute. Is this picture clear to all of you?
No,
Yes. So
clarity left.
okay, so I'll explain. Here is the various process which are basically involved in during the process of biofilm formation. The extreme right left corner is the mass transfer, and this arrow basically describe the first processes, and this side mostly describe the slow processes. So the first processes are basically the mass transfer. Then the slow process of hydrodynamics comes under slow process. Biomass growth comes under slow process. Substrate diffusion is comes under the first process. So based on the study, it is like from this graph. 1 minute, I will try to show you the graph better. Yeah. So okay, now it's visible, the graph.
No.
Okay, so as you can see, the first process are mass transfer, reaction, convection, and viscous dissipation. These are comes under the first processes, where under the slow process basically comes biofilm formation, that is the detachment of biomass decay, biomass growth. So mass transfer, which basically involve reaction and substrate diffusion, and hydrodynamics that involve basically the convection and viscous dissipation. So according to the um, So according to the study, it was found that the biomass growth has the one of the slowest process as the given description. Now moving to the next question. Um, this,
Slide is not visible.
1 minute. Okay. Now move to the next question. That is, while using a UV spectroscopy for concentration of the analyte of uh, 0.1 and 0.2 millimolar, the view is millimolar, the absorbance rate are 2 and 3 units respectively. What is the concentration if the absorbance rate is 2.5 unit? Kindly solve the question. Hmm. Any idea? Please kindly solve this question and tell me any number or any idea. Okay, Mr. Sujit Verma, what will be the what will possible answer according to you?
I'm doing tech
Okay,
it.
okay.
Actually, I'm traveling. Just I'll take some minutes.
No, but any approximate answer will be fine by seeing the question. What will be the like any approximate answer you can tell if you don't not able to solve the question.
You say 0.15.
Okay. How much?
0.15 millimole.
Okay. Anything else?
0.15. 0.15.
Okay. And any other answer? So the correct answer of this question is here we assuming the linear dependence. So we are assuming the linear dependence of the concentration C on the absorbance A. And we basically use the straight line equation where we put C, which is basically the unknown concentration, minus C1, the concentration of the initial, the first one, that is 0.1, C2, that is equals to 0.02, minus C1, then again 0.1. Now moving to the absorbance A, this is the absorbance of the unknown sample, which is comes at 2.5, then A1. So the analyte concentration is 0.1 millimolar, the absorbance is comes as 2. So we put 2 here. Then the A2, that is the concentration having 0.2 millimolar, which absorbance read is comes as 3. So here we put 3 minus 2. So the value is comes as C minus 0.1 divided by 0.1 equals to 0.5. So multiplied by it comes as 0.05 plus 0.1. So the concentration is comes as 0.15 millimolar. So anyone have any doubt? Okay, now moving to the next question. Mass spectroscopy is used for measuring the molar mass. One of the mass spectroscopy technique which uses the matrix in which sample is placed. Sample is placed in the matrix, and this process is known as which one? ESI, time of flight, MULDI, and EI. Any answer?
Is it MULDI?
Okay, anything else?
MULDI.
So what are the main component of the mass spectroscopy? Okay, and okay, so I'm asking a basic question. What is the principle of mass spectroscopy and why it is used mostly?
Gives us mass to charge ratio. Molecule.
And what all the components?
So it has ionizing unit detector.
So MALDI is which process? It is a ionization technique or detector or which process?
Ionization.
Okay. And anyone have any different answer? Okay, so here basically we describe the correct answer is MALDI, and there are basically two processes we are going to compare. The first one is the electrospray ionization, and this is matrix assisted laser desorption ionization, which is also known as MALDI, and this is ESI. So these two are the more major ionization technique that is used during the MS process. So in the ESI, what happened? The highly charged aerosol is generated from sample in solution, and this sample started to shrink and due to the evaporation process, and the charge density increases until the Coulombic explosion occurs, and producing the dotted and it is burst out and produces the dotted droplets. This process continue until the individual ions are generated. The major limitation of this process is this sample need to be soluble, and ESI is basically applied to charged polar or basic compounds. The next one, the MALDI. MALDI, where is the laser desorption ionization generates ions by ablation from surface using a pulsed laser. So in this process, basically samples are placed on a matrix or surface. Uh, so here the matrix which is used, they are basically crystallized with the sample. As the sample is irradiated, a pulse of dissolved molecule is generated uh, due to this plume, and because of this plume that ions are mostly generated. Apart from that, several other processes are mostly used for ionization. One is the inductively coupled plasma mass spectroscopy, that is ISMS, first atom bombardment, and many more. So here the correct option is MALDI. Now moving to the next question. Reverse phase chromatography is. Any idea what the stationary phase and the uh, mobile phase in reverse phase chromatography?
Non-polar stationary phase and a polar solvent.
Okay, and what is the class like normal chromatography? What is the stationary phase and mobile phase?
It will be polar stationary phase.
Okay. Any other answer? So basically chromatography, any chromatography has two
Polar
phases.
stationary phase and solvent.
Okay, so reverse chromatography phase, what is the correct answer? So what is the correct answer? Non-polar stationary phase and a polar solvent, right?
Yes.
Okay. So the correct answer is non-polar stationary phase and a polar surface. So in any chromatography, there are two phases. One is the mobile phase and one is the stationary phase. In the case of classic chromatography, the mobile phase basically a non-polar organic solvent and the stationary phase is a polar phase. But where is in the so what happened when a mixture of different molecule is passing through the column, which are the polar constituent of that material dissolve in the in the solvent, and it's tried to interacted with the polar stationary phase, while the non-polar constituents tend to get eluted along with the solvent. So the first eluted product will be the hydrophobic materials or the non-polar materials, whereas the polar materials, the elution time is a little bit more. Whereas in the case of reverse phase chromatography, the situation changes where the mobile phase is basically the polar solvent, whereas non-polar, the stationary phase is basically the non-polar stationary phase. When in this case, when a different constituting material is passing through, the hydrophobic content try to get interacted to the stationary phase via hydrophobic interaction, whereas the polar material and passing through the reverse phase chromatography and eluted fast. So can anyone tell me what is the mobile phase most commonly used in the case of reverse phase chromatography? What are the material most commonly used as a solvent? So can anyone tell me what all the solvent are most commonly used in the reverse phase chromatography? Any idea? Okay, so basically the water blend of water and miscible organic solvent are most commonly used, and among the organic solvent we have basically used the acetonitrile or methanol, and sometimes several ion pairing agents such as trifluoroacetic acid is also used. The purpose of organic solvent used for the in reverse phase chromatography is to maintain the polarity at long enough level for the solute to dissolve in the mobile phase and yet high enough to facilitate the binding of the preferred molecule with the stationary phase. Now moving to the next question. In a time of flight mass spectrometer, an ion of molecular mass 400 Dalton reaches the detector at 1.5 minute. So an ion of 500 Dalton will reach at how many minutes? Kindly solve the question. Hello. Does anyone able to solve the question? Dr. Krishna? Anyone else? Miss Anisha? Should I wait for some time or should I solve the question? Miss Neha Jha? Okay. So anyone have any answer? Daisy?
1.875.
Okay. Anything else? Anyone have any different answer? Anyone else? Okay. So here I will tell you where the formula is coming from. The formula is coming from a simple equation, that is kinetic energy Ke equals to half half m v square, half mv square. From there we find
You're
out the
writing.
yes.
We can't see your writing.
Just a minute. You're not able to see the writing.
No, ma'am. No, ma'am.
Okay. Okay, just a minute. Slide is visible, right? Or slide is also not visible.
Yes, slide is.
Slide is visible.
Okay, just a minute. Okay. So here so where use the simple formula, that is, now the writing is visible. Hello.
Yes.
Yes, ma'am.
Yes. So that now kinetic energy equals to half mv square. We use the formula. From there, we found V equals to m sorry. Okay. V equals to comes as two ke 2 ke 2 into kinetic energy divided by m. Is that solution clear to everyone? This step?
Yes, ma'am.
Okay. So now we know V equals to T divided by time. Is that clear to everyone? That one, this part is clear to everyone. V equals to d by t. So from there, we found that t equals to this formula. T into m divided by 2 into kinetic energy. Okay. Here, this d is the flight's tube length. Here, T equals to d is the flight's tube length, m is the mass of the particle, and kinetic energy is the particle's kinetic energy. So, if we consider that the kinetic energy of all the particles are same, then we can say this part especially, this entire part is basically a constant value. This entire part is constant. So constant. So we can say T is directly proportional to the root of m, or root of the mass of the particle. So from there we can say T1 divided by T2 equals to root over m1 by m2. So now if we put all the formula here, so 1 by m equals to T, 1.5 divided by T equal to root over 400 by 500. The will get the correct answer. So please calculate and tell me the correct answer. Okay. So what is the correct answer? The correct answer is come around 16.76. Sorry, not 16.76.
Is it 1.68?
Yes, the correct answer is 1.68. So the correct answer here is it is not 1 point. This one not. That is the correct answer is 1.67 minute. Sorry for the inconvenience. Okay. Now moving to the next question. The release of enzyme lactate dehydrogenase from cell indicates. Any answer? Can anyone tell me where lactate dehydrogenase is mostly found?
Ma'am, it's cell necrosis.
Okay. Anyone else? Any answer? Yeah. How? Okay, so the correct answer here is the cell necrosis. So lactate dehydrogenase basically a stable cytoplasmic enzyme that is found in all the cells, and it basically helps to rapidly release into the cell culture supernatant when plasma membrane are damaged. And it is a key feature of cell undergoing apoptosis, necrosis, or any other form of cellular damage. The LDH activity can easily quantified using the NADH produced during the conversion of lactate to pyruvate, or to reduce a second compound in a coupled reaction into a product with property that can be easily quantified. So here the protocol that most commonly used, the reduction of a tetrazolium salt INT by NADH into a red water-soluble formagen class dye by absorbance at 492. From there we can find that the cell has a necrosis or not. Now moving to the next question. Complement activation does not lead to. It's a classic question from immunology. Can anyone tell me the correct answer?
Blood clotting.
Sorry?
Blood clotting.
Blood clotting. Okay. Anyone, any answer? Any different answer? Okay. So the correct answer is blood clotting. So now I'm going to say there are three main effects that is created due to the complement activation. The first one is the lysis of cell. Lysis, lysis of cell. The second one is the generation of inflammatory mediators, or here recruitment of the inflammatory cells. Third one is the opsonization, that is the enhancement of phagocytosis. Now, there are three basically pathway. One is the classical pathway, one is the lectin pathway, and another one is the alternative pathway. So, in the case of classical pathway, it is an antibody dependent pathway where uh, it is basically this pathway is triggered by the formation of soluble antigen antibody complex or binding of the antibody to the antigen present on the target cell surface. Whereas in the case of alternative pathway, it is a spontaneous hydrolysis process where it is directly activated by the pathogens or antigens, that is the bacterial cell surface components. The third one is the lectin pathway. It is basically the antibody independent pathway but is quite similar to the classic pathway. Now, so if we go, there are several different methods. So these are the three effects. So according to the study, the blood clotting is not related to the complement activation pathway. So I'm not going to discuss the entire process. Do I need to discuss the entire process of the stages of the complement activation? Okay, so now to the next question. MTT assay is performed to study. Okay, so can anyone tell me what is the difference between lectin pathway and classical pathway, alternative pathway?
No, ma'am, don't know.
Sorry?
Don't know, ma'am.
Sorry, actually your voice is not audible, sir. Can you tell me the answer again or can you write down the answer?
No, ma'am, I said we don't know. I don't know.
Okay. So what is the correct answer of this question? MTT assay is performed to study.
Cell metabolic activity.
Okay, and can anyone tell me what is the principle of the MTT assay?
Actually, it is used to differentiate a viable cell. So, if because of enzyme activity, this MTT that will be converted into another product. So, from that we can understand the viability of the cell.
Okay. So it's basically used to study the cell metabolic activity. So basically, it is work on the principle where the MTT, that is 3,4,5 dimethyl thiazole 2-vinyl 2,5 diphenyl tetrazolium bromide. So that is the MTT full form. It is basically help to cleavage the tetrazolium ring present in this material by the dehydrogenase present in the active mitochondria of living cell and estimate the cell viable cells. So basically what happened, the MTT the MTT will be reduced or the tetrazolium ions are opened by the metabolic activity of the bacterial cell, which produce the color. uh, so based on the study from the color, we can find out we measure the wavelength of that particular color, and then we can find out the metabolic activity of the cell. It is basically transfer the water soluble MTT dye into a insoluble formazole. So now moving to the next question. In the equation n lambda equals to 2d sine theta, the d is
A, distance between planes.
okay. Anything else? Okay, the correct answer is distance between planes. If you see this photo, the d is the distance between planes. The theta is taken this angle. So it's according to the Bragg law. The correct answer is the distance between planes. Now moving to the next question. Crystal has A equals to 2, B equals to B equals to 2, B equals to 3, and C equals to 4 angstrom, and alpha, beta, and gamma equals to 90 degree. What is the length of the longest diagonal? Anyone able to solve this question? Okay. So the correct answer, the unit cell is considered as a cuboid, which is given as one table according to the table. So the longest diagonal is the volume diagonal, and the length is calculated as L equals to root over of a square plus b square plus c square. So a square equals to 2 square, b square 3 square, and 4 square is c square is 4 square. So the coming around 2 root over 29, that is comes as 5.38 angstrom. Now moving to the next question. If X-ray of a wavelength 100 angstrom is incident on an atom at an angle 90 degree, what should be the value of D for first order spectrum? Hello, am I audible? Hello.
Yes, you're audible.
Yes. So anyone able to solve this question?
Fifty angstrom.
How do you solve it?
N lambda equals to 2d sin theta. N equals and sin theta sin 90. So 2 into 1. So 100 equals to 500. So 100 by 250.
Okay. Anyone else have any different answer? So the correct answer is 550 angstrom. So what happened? We take the formula of Bragg equation, that is n lambda is equal to 2d sin theta, while lambda equals to 100 angstrom, that means 10 to the power 8 meter. Now moving to the next one, that is n equals to 1, because here is given as first order spectrum, so we took it as n equals to 1. Now sin theta 90 degree is equals to 1. So therefore we can find that D equals to 50 angstrom. So can anyone solve the second this question using the, if we want to find the third order spectrum?
One 300 by 2.
Sorry.
150. 100 into 3. 300 divided by 2. 150.
150. Okay.
Because third order, no? Third order means n equals to, so 300 divided by 2d sin theta.
Just a minute.
Let's say
3.
2 divided by 2. 150.
Okay. Now moving to the next question. If the angle of incidence is 30 degree, then the wavelength of the first order spectrum is?
Same formula, madam.
Sorry.
Same formula. I don't have any pain. travel.
Sorry, your voice is not clear.
Actually, I'm traveling now.
Okay, so please you can write down in your chat box. I'll see then because it's not very difficult to hear you.
Okay.
Okay, thank you. So what will be the correct option for this question?
I think B. B. Only B.
Anyone else? Correct option is option D. So basically here n we use the same equation, that is n lambda is equal to d sine theta. So here n equals to 1 and theta equals to 30 degree, which means lambda is equal to 2 into d into sine theta. So sine 30 degree equals to half. So lambda is comes as d. So now I will give some question in the chat box. Please check the chat box and
Hello.
hello.
I have one doubt.
Sorry, even actually that's why I'm telling. Please kindly write in the chat box because I have facing some difficulty in hearing the voices. So it will be better. Whoever any doubt, please put it in the chat box. Okay, I put a question in the chat box. The question is the scattering of waves in Bragg's law experiment is due to Einstein scattering, Rayleigh scattering, Newton scattering, and inelastic scattering. Why? Anyone have any different question? Answer? The correct answer of this question is relics scattering, because in Bragg's law experiment, the phenomenon is observed due to the relic scattering, that is, a movement of charges in re-radiated with the wave of same frequency. So this scattering is related to the relic scattering. Now moving to the next question. The Bragg's law is a special case of law diffraction. True or false? Law diffraction. Okay. The correct answer is true, as law diffraction is the one used in X-ray crystallography. Bragg's law is only a special case of law diffraction, with the condition that the incident angle be equal to the scattering angle, and the wavelength is an integer times with the path difference. Now moving to the next question. The next question is, what is the most two common sources that is used in illumination sources that is used in UV visible spectrophotometer?
Repeat the question.
Okay. So kindly solve. Now I'm giving a question. Please solve this question. Okay, so the question is, we have stated that typical ranges of UV visible spectrophotometer is 195 nanometer to 900 nanometer. What is this range in hertz? Okay. So the correct answer of this question is 1.53 into 10 to the power 15 second inverse or hertz for the case of lambda is equal to 195 nanometer, where lambda is equal to 900 nanometer. The frequency is 3.33 into 10 to the power 4 hertz. So what happened here? We take the formula, Planck's formula, that is h equals to lambda, or we can give the frequency is equal to c by lambda. So here we put that c as 3 into 10 to the power 8 meter per second divided by wavelength in 1.95 10 to the power minus 7 meter. So the final value is come as 1.53 into 10 to the power 15 second inverse, whereas lambda 900 is comes as similarly comes as 3.33 to 10 to the power 14 second inverse. Now moving to the next question. So what would be the concentration of the solution B if you obtain an absorbance of 0.05 at a lambda max equals to 290.5 nanometer and molar absorbability of 14,500 mole inverse centimeter inverse at 290.5 nanometer. Kindly solve this question.
Hi guys.
Anyone able to solve this question? Anyone able to solve this question? Okay, so for this question, you have to directly put the formula of B.R. Lambert's law, that is A equals to eta CL. A equals to eta CL. So here you standardly considered B equals to 1 centimeter or the path length equals to 1 centimeter. So now you can go for 0.05 divided by 14,500 into 1. So that from there you can find that C equals to 3.4 into 10 to the power minus 6 molar. The correct answer is 3.4 into 10 to the power minus
Can't see you writing.
Sorry.
I'm not able to see writing.
Please check in the check in that chat box. Okay, so the question here is, what would be the concentration of the solution B if you obtain the absorbance of 0.05 at the lambda max to 290.5 nanometer and the molar absorbability is 14,500 molar inverse centimeter inverse. Now moving to the question. Now if we go to the formula, we can find it. We can use the formula of Beer-Lambert's law, that is A equals to eta CL. So here eta is equal to molar absorbability, C equals to concentration of the solution, and L equals to the path length. So as the path length is not given in the question, we assume it as a 1 centimeter. Assume L equals to 1 centimeter. Okay. So now if we put the question directly, it's come as A equals to, can they tell me the what is the absorbability in the question? It is comes as 0. Absorbance is come as 0.05, 0.05 divided by 14,500 into 1. So what will be the value? Please do the calculation and tell me the value.
3.44 into 10 to the power minus 6.
Okay, the correct answer is that is comes as 3.44 into 10 to the power minus 6. What will be the unit? What is the concentration unit should be applicable here? The unit will be molar. Okay, so if we do the unit dimension, you can check the absorbance has no unit. So eta is basically mole inverse into into, sorry, so here comes mole inverse semi inverse. So this is the formula of that your absorbability, that is a unit. Then we'll go for concentration. Concentration unit we have to find out. Then we'll go for path length. Path length we'll consider it in the cm or centimeter. So in both case centimeter will be cut. So concentration unit will be in molar. Okay. Now the question is clear to everyone.
Yes, ma'am.
Okay. So do you have any doubt in today's question, today's session?
No, ma'am.
So does anyone have any doubt in today's session? So thank you everyone. We'd like to conclude today's session.
Thank you.